Okay, so we're looking at the second video in trigonometry, and basically this is the most important part, so we just need to be really focusing on what we're doing here. So I'll just minimize that. So if I've got a right angle triangle with an angle down here, the triangle can be enlarged to a second triangle or a third triangle, and the angle in the bottom corner is still the same. So what I'm saying is there's a small triangle, there's a bigger triangle, and then there's a really big triangle, and the angle is still the same, and the right angle is still the same. Okay, so that's the first part, just to explain that I can enlarge a triangle and the angle in the corner doesn't have to change. Okay, so you don't need to copy that, just come across when you're ready. Okay, so what I've got is those three triangles from the first page. I've got the angle in the bottom corner, and this is the first one. So again, just to remind yourself, opposite is called the hypotenuse, opposite the right angle. Opposite the angle is the opposite side, and the other side is called the adjacent. So I've got H for hypotenuse, O for opposite, and A for adjacent. So I've got three triangles. I had a small triangle, a middle triangle, and a big triangle. And so I've got the first adjacent, the second adjacent, the third adjacent, the first opposite, the second opposite, the third opposite, the first hypotenuse, the second hypotenuse, and the third hypotenuse. And what we have is a ratio of sides. So if I put the opposite side, which is a length, and I divide it by the adjacent side, it would be the same for all three triangles. Whatever those numbers cancel down to, 3 over 5 or whatever, each of the triangles, the ratio will be the same. And the same with opposite and hypotenuse and adjacent hypotenuse. And the reason we have them in this order will become apparent on the next page. So the important thing is, when you divide sides, that's called a ratio, and it doesn't matter how big the triangle is, the division of sides is always the same for some angle in the bottom corner. And you don't have to worry about what the angle is at this stage. You just have to know that the ratio, so the ratio stays the same. And this is to do with similar triangles. Okay, so you did a topic in year 8 called similar triangles, and so what we're doing is just something on similar triangles. Okay, so again, you don't need to worry about this. Just look on the next page and see what happens. Okay, so the ratios that I looked at on the previous page, opposite over hypotenuse, adjacent over hypotenuse, and the opposite over adjacent, these ratios have names. And the first one is called the sine ratio. And on your calculator, they abbreviate it to SIN, which is not sin, it's sine. Okay. The adjacent and hypotenuse is called the cosine ratio. And on the calculator, they abbreviate it to cos. And the last one is called the tangent ratio. And on your calculator, they're just abbreviated to tan. Okay. And the way to get them not confused is there's like a little mnemonic. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so some people just learn as so, car, toa, or you can learn it like a little mnemonic like some old hobos can't always hide their old age. So that's just one way that some kids have remembered over the years, but some kids just write so katoa at the top of the page. So otherwise it's some old hobos can't always hide their old age. So that's the name of the ratios. Okay, so let's have a look at writing out what the ratios are for three triangles. We'll do some together and then you get some practice. So first thing we do is we name the sides. So we've got hypotenuse, opposite, and then adjacent. Hypotenuse, opposite, adjacent. Hypotenuse, opposite, and then adjacent. So in this particular triangle, I've got numbers on the sides. So the sine, so again, so, ka, toa. So sine is opposite and hypotenuse. So opposite is 3, hypotenuse is 5, so that's the answer. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. So they're the ratios for sine, cos, and tan for that particular angle. Okay. And again, you don't have to have numbers, you could have letters. So sine for this one is m over p, cos is n over p, and tan is m over n. Okay? Or you don't even have to have numbers, you can just use the vertices. Okay? So sine is AC over AB, cos is adjacent BC over AB, and tan is opposite AC over adjacent BC. So copy that down, and then come across when you're ready. Okay, so practice those yourself. This is the last slide, so when you're ready, come back live. Okay, you might be back. So hypotenuse, opposite, adjacent. Oh, forgot to put the right angle in. Hypotenuse, opposite, adjacent. Forgot to put the right angle in again. Hypotenuse, opposite, adjacent. So sine is 5/13, cos is 12/13, tan is 5/12. Sine is 12/15, cos is 9/15, tan is 12/9, and then you can cancel those fractions down. And the last one is AC over AB, cos is BC over AB, and the last one is AC opposite over adjacent BC. Okay. So again, this is just a skill to build up, and that's all you need to know for the time being. Thanks, bye.